Welcome back to my sessions on suspension system. I am Professor Adimurthy, Faculty, Department of Automobile Engineering, BLDES Vachana Pitamaha, Dr. P.G. Halakatti, College of Engineering and Technology, Vijayapura. In the last session, we discussed about the importance of shock absorber and various types of shock absorbers, particularly the hydraulic shock absorbers and the gas-filled shock absorbers, and their related merits and demerits in the earlier session. In today's session, we are going to discuss about the role of stabilizer or anti-roll bar in an automobile as a part of a suspension system. Now, what is meant by rolling? Rolling is nothing but the rotation of a vehicle about the longitudinal axis. This may happen whenever one side of the wheel passes over a irregularity or a bump, or during a hard steering or during hard cornering process. And this may lead to the accident or toppling of the vehicle or rolling over of the vehicle. And the stability will be lost, which may lead to fatal accidents. To avoid this kind of situations, a special device is provided as a part of the suspension system, and that is nothing but the anti-roll bar or the stabilizer bar, as it improves the stability of the vehicle and avoids the rolling of a vehicle during the cornering or due to road irregularities. It is named as anti-roll bar or stabilizer bar. Here in this diagram we can see the arrangement of anti-roll bar or the stabilizer bar. Basically, it is nothing but a simple bar-like or a tubular structure which is connected to the lower wishbone arms of the left and right sides of the wishbone suspension system. Here you can see left side is connected to the lower wishbone arm of the left wheel, and another end is connected to the lower wishbone of the right wheel, right suspension system. So here the bar is supported with the help of bushes which are connected to the frame. So it is interlinking the left side and right side of the suspension system by connecting the lower wishbone arms of the both sides. So the another view of this anti-roll bar arrangement, from this diagram you can have a better understanding of the arrangement of the anti-roll bar or the stabilizer bar. Here you can see this brown colored portion is nothing but the anti-roll bar. One end is connected to one lower wishbone arm and the another end is connected to another wishbone arm, and it is supported in the bushes fitted with the frame where it is not shown. And this is the upper wishbone, this is the lower wishbone, and this is the cross member. And you can also observe the shock absorber located between the cross member and the lower wishbone arm. So this kind of arrangement is called as the stabilizer bar or the anti-roll bar. So what is the requirement of this anti-roll bar? So when one road wheel is deflected more than the other wheel, and there is a tendency that the vehicle will be rolling in one direction. So to avoid this tendency, the anti-roll bar is used in the form of distortion bar. So this is fixed to the springs, as I told you, the lower wishbone arms, and this is supported in the bearings. And consider a situation when a vehicle rolls out such that one wheel moves up, which decreases the load on that side and causes the other end move in the downward direction and undergoes a twisting movement and encounters the tendency of vehicle to roll out, thereby providing stability against the lateral forces. So by providing this anti-roll bar or the stabilizer bar or the sway bar, so there is the chance of avoiding the rolling of the vehicle or rollout of a vehicle during hard cornering or due to the road irregularities. And this kind of arrangement you can see in various Indian vehicles. For example, a Bajaj Tempo, Tata LPTs, Tata Sumo, Mitsubishi Lancer car, Tata Mobile, premier diesel car. Of course, these are old models. Nowadays also in many of the systems, that kind of arrangement can be observed. Particularly in old SUVs, you can find this kind of arrangement, which is called as anti-roll bar. Now let us try to understand the differences between the air suspension system and a conventional spring suspension system. So, important differences are listed here. In air suspension system, the air springs or air bellows are used, whereas in conventional suspension system, leaf spring or coil springs or both can be used. Stiffness of the system increases with the increase in deflection in case of air suspension system, whereas stiffness of the system decreases with increase in the deflection in case of conventional spring suspension system. Increasing ride comfort and decrease in noise level is one of the advantage in case of air suspension system, and relatively riding comfort is less in case of the conventional suspension system. In air suspension system, wheel deflection is controlled by automatic control devices, whereas in conventional system, there is no automatic control device. Air suspension system, springing rate varies much less between the laden and unladen conditions, as we already discussed these points, and the springing rate is more as compared to air suspension system in case of a conventional system. And fatigue to the driver and passengers is very much less in air suspension system, and relatively it is more in case of conventional system. Air suspension system consists of air compressor, reservoir or accumulator, leveling valves, air springs, and the hoses connecting these various devices. Whereas conventional system consists of leaf spring, coil spring, shock absorber, etc. And if you consider the application as we discussed in the earlier class, this air suspension system is used in luxury vehicles and the luxury cars, such as a Volvo bus, for example, and any other luxury cars. Whereas the conventional spring suspension system is used generally in heavy and medium duty vehicles and regular passenger cars, etc. So, these are the comprehensive list of the differences between the air suspension system and conventional spring system. Now let us have a comparison of regular telescopic shock absorber and a gas-filled shock absorber. In the earlier sessions, we compared the construction and working principle of both shock absorbers. With that knowledge, we can have the comparison of these two. And telescopic shock absorber, only oil is used, whereas in gas-filled shock absorber, we are using both oil as well as the gas, and the gas is nothing but generally the nitrogen gas is the working medium here. And in case of telescopic shock absorber, the tolerance to the heat is very less, whereas it is better in case of the gas-filled shock absorber. In telescopic shock absorber, due to the up and down motion of this oil between the valves, there is a chances for the formation of the foam. Whereas in gas-filled shock absorber, the minimum foaming will happen, and it is designed to reduce the foaming of oil. Atmospheric conditions do not affect the system in case of shock absorber telescopic type, whereas in gas-filled, it will have a little effect of atmospheric conditions on the working of the system in case of a gas-filled one. Operating cost of telescopic shock absorber, hydraulic shock absorber is relatively less, whereas the cost of nitrogen gas is more, and it is in comparison with the hydraulic oil. Relatively, maintenance is easier in case of hydraulic shock absorber, whereas in gas-filled shock absorber, it is relatively difficult than the regular hydraulic shock absorber. And when you compare the damping effectively is less in case of the regular hydraulic shock absorber, whereas better damping is obtained in case of gas-filled shock absorbers. These are the important differences between the hydraulic shock absorber and the gas-filled shock absorbers. Similarly, we can have a comparison for independent suspension system and rigid axle suspension system. So the facts we have already discussed. Here lighter springs are used in independent system, whereas heavier springs are used in rigid axle suspension. Unsprung weight is low in independent system in comparison with the regular rigid axle suspension system. And the independent suspension system provides better tire life because of the stability in comparison with the rigid axle, whereas initial cost is high for the independent and it is relatively low for the rigid axle. Maintenance requirement is more in case of independent suspension system in comparison with the rigid axle. And the possibility of tilting is very minimum in case of independent suspension system, whereas the axle tilts and wheels may not remain vertical in case of rigid axle suspension system, leading to the reduction in the stability of the vehicle. Steering geometry is not altered with the spring deflection in case of independent suspension system, and there is chance for altering in case of the rigid axle suspension system. And since it occupies less space, more space is available in the engine compartment in case of independent suspension system, whereas relatively less space is available in the rigid axle suspension system. Independent suspension system provides a better and softer suspension because of the low spring rate and large wheel movements, whereas the suspension is harder in comparison with independent suspension system in case of a rigid axle suspension system. Now let us go through the troubleshooting of suspension system, and the major problems that with the suspension system encounters is: one is the rough ride, second one is the suspension system too flexible, and third one is the sagging of springs. Now let us go through what are the reasons for the rough ride. So if it is a rigid axle suspension system, the reason for this rough ride may be the rusted leaves, which increases in the excessive friction. So the lubrication, proper lubrication and maintenance of the springs will reduce this friction and the ride can be smooth. And another reason can be the pins and the shackles. If the shackles are seized, which should be set right, and the proper movement should be provided to the shackles. Relative movement should be there between the pins and the shackles. Sometimes the shock absorbers may be defective, leading to the rough ride, and it needs to be repaired or replaced. If lubricating pads at the end of the leaves are damaged, it also leads to the rough ride, then these should be replaced. In case of independent suspension system, the reasons for the rough ride can be the pivots of the suspension arms may be seized. So the free movement of the arms will be lost and it leads to the rough ride, and the remedy is to immediate lubrication for smooth movement of the arms. In case of torsion bars, if the adjustment is not correct, then it will lead to the rough ride, and proper adjustment is required to get the proper ride conditions from the suspension system. The second important problem we can identify with the suspension system, it is too flexible. Means over damping may happen or less head damping may happen with the suspension system. And what are the reasons for this suspension system too flexible? Here the specification of the springs that are used and with this system, if they are not matching with the manufacturer's specification and if proper lubrication is not provided, there may be chances for the flexible suspension system. See, the remedy is to clean the springs thoroughly and properly lubricate. So if unspecified lubricating oil is used, it may spoil the suspension system and it may become too flexible. And the springs may have become weak due to constant use and they have become too flexible. The spring rate will be changing. So only remedy is to replace the suspension springs. And some of the leaves may be broken. And then also there will be suspension too flexible and the Remedy is to